What I'm going to do is take you through a historical journey of the role that fluvial geomorphology has had in the Mediterranean, starting off, bless him, with Claudio Vita Finzi's work. His main protagonist, I should have actually put Karl Butzer in there as well, but Van Andel. Then talk about some of the major developments since the mid-90s in the Mediterranean. Focus then a little bit in terms of the new meta-analysis, and I'll explain that in a second, that we've been doing. And then focus on the topic of this conference, because I was astounded what dropped out of this exercise, and you might unpick it. I hope you do in some way, because I am slightly astonished in terms of what's come through. For Mark, I've dropped in the desiccation event in terms of the Millennium AD, particularly in terms of the very famous AD 365 event, which affected much of Western Crete. And then just at the end, I'll give you some sort of heads up in terms of where I think we perhaps need to go. Okay. A mugshot of the man himself, Claudio Vita Finzi. I can see Neil smiling. Looks a bit, yeah, he's normally more happy than that, but anyway. He is, yeah, no, it's a miserable, anyway. I think it's always very interesting just to sort of ponder how far we've come since his book was published in 1969. You may not be able to see much of the details here, but in terms of his younger field model, it was based on 5 radiocarbon dates and a coin. And obviously, Karl Butzer, who, when he reviewed the Mediterranean valleys volume, pointed out that there was perhaps a problem. There was more than one younger fill. But I actually think Claudio was right for the wrong reasons. And we can talk about that a bit later. By chance, I happened to work in the mid-80s, where Claudio did much of his early work in Epirus, not looking at Holocene stuff, but actually working with Jeff Bailey, looking at late Pleistocene records in the Clavie project with Clive Gamble. And that's how I appointed my first PhD student, which was Jamie Woodward, who I then worked with thereafter. Okay. His protagonist. There was a picture of Van Andel, but I actually preferred this painting. I think it was rather... My wife's an artist, she's actually a printmaker, but I just rather like this. As was pointed out, Karl Butzer, in his review, said it was problematic. There was more than one younger fill. And what's interesting in terms of Van Andel's and Pope Van Andel's work from the late 80s through to the early 90s is they obviously demonstrated, this is just Greece, the multiple periods of alluviation. They, instead of putting it within a climatic framework or straitjacket, they put it in an anthropogenic straitjacket. But when you actually look at the dating control of these periods, it's very poor. When you actually look at the relationship to some of the so-called land use changes, those are weak as well. And the main thing that they suggested was this idea of this economic prosperity collapse model with the idea in Mediterranean environments, when you get an economic decline, field systems go into disuse, erosion occurs, and so on. Actually, I've been working in the Mediterranean for about 35 years, particularly looking at historical evidence in terms of major floods and land use change, and that really just doesn't happen. These landscapes actually heal pretty quickly indeed. Okay, if we then roll it forward, I'm pretty dyslexic. How do I pronounce this gentleman's name? Thank you. I think he was, and his team, were ahead of the game. Actually, there was a paper published in 1984 where they actually started to compile some of the dated soils and flood sequences, particularly in Greece. And John Bintliff reviewed this in a paper in 2002 and suggested that since about 3000 BC, following the establishment of a semi-arid climate in the Mediterranean, we had cyclical shifts in climate, which was pre-adapted to erosion. And then obviously Gerardo Benito, a good friend and colleague of mine, and actually has been involved in the meta-analysis, which I'll talk about in a second, wrote a review in 2003 emphasising this pattern. The details perhaps are not important, but there is the major soil development around about 3000, 1000 BC. You can also notice, which they didn't spot at the time, a significant hiatus, a major incision event in many of the records across the Mediterranean. But The problem with these analyses was that there were relatively few radiometric dates. There was, I think, a very limited process understanding of the way that land use impacts hydrology and sediment dynamics. At the time, there were very few indeed high resolution. For me, working over Holocene timescales, historical stuff is different. Centennial or better resolution in terms of Holocene hydroclimate change. And generally speaking, river scientists like myself and sedimentologists tended to focus on the larger coastal systems as opposed to a lot of the mountain, steepland environments which actually characterise most of the Mediterranean. Okay. So since the mid-90s, there's been a series of developments, and I run through these relatively quickly, and what I'm going to focus on is this recent meta-analysis compilation. I suppose that the first development we saw, and this gives me an opportunity to show a picture of a very good friend of mine, John Lewin, standing there very manfully in very short shorts, I think in 1990, where we were working in, I shouldn't really have said that, should I, in Euboea. And the significance of this is that we started to focus on the historical timescales in terms of major floods, alluviation, and soon began to realise, in terms of the last 200 or 300 years, there have been huge changes in these steepland systems, cutting and filling of up to 5 metres, mostly related to very large historical flood events. Glenn Mars, who was a PhD of mine, a student of mine who works with me in Crete, used lichenometry to actually date some of these flood events and began to relate these to the NAO. What we can see is this period of negative NAO between the 1940s and 1960s seems to suggest there is a clustering of extreme events. This is from the Aeagean system in southwest Crete. But actually, when you look in detail at the coincidence between these flood events and the NAO, it's not straightforward. And as you'll see in a second, I think in terms of the eastern Mediterranean, for what it's worth, it's actually positive phase of the NAO, which seem to be characterised by more extreme hydrological events. Okay. Gerardo Benito, postdoc of Vic Baker, University of Arizona at Tucson, pioneering work looking at bedrock systems. This is the Aegis, published in 2003. Slack water deposits. These are confined gorges, major flood events which overtop, and he's got a good flood record which starts in the early Holocene and some major flood events in the historical period. So he was able to give discharges to these, and also he was able to date them using small sample AMS. Last but not least, with colleagues, particularly Jeff Duller, my colleague at Aberystwyth, luminescence specialist, we started to apply over Holocene timescales. We've already done this in terms of late Pleistocene work we've done in the Ebro system in northeast Spain, particularly in Fuller, of applying OSL techniques in terms of dating individual flood units within steepland systems. And as an example from the Anapidaris system in southern and southwest Crete. So, those are the major developments that I think we've seen since the mid-90s. Since about 2003, started by myself and John Lewin, we realised that there was a need to try and aggregate data, fluvial data, in a more thoughtful way. This doesn't mean that we are stamp collectors in terms of radiocarbon dates or luminescence dates. Actually, most of this work has been done ourselves. Okay? So we are field-based geomorphologists, but we decided we needed to actually join up this information because fluvial records tend to be discontinuous. They tend to be spotty. One single catchment is not going to give you a full Holocene history. So, started in 2003 for the UK, we've done it in Poland, we've done it in New Zealand, Russia, and it goes on, American Southwest. We've developed a way of compiling dated fluvial units, initially using radiocarbon, but as you'll see in this example here, using radiocarbon and OSL. And this is part of a special issue that's going to be eventually published by Katina when me and Gerardo get finishing to edit it. But as I say, when I was invited, when I was actually in New Zealand to attend this conference, it forced me with Gerardo and colleagues to do this. So this is a paper currently in review. What we've done is take 568 dated fluvial units. These are flood units, okay? What we do is actually look at the stratigraphic and sedimentological records associated with all these fluvial deposits from the Iberian Peninsula, from southern France, southern Italy, North Africa, and the Eastern Mediterranean. And on the basis of the sedimentology, we assign these or not to a discrete flood event. So this is not simply taking all radiocarbon dates in fluvial units or all luminescence dates in fluvial units and putting them into this analysis. We are selective in terms of picking out flood units, fluvial units, which we can relate to extreme events. So what we've done is divided the Mediterranean into 7 regions on the basis of precipitation and also rainfall seasonality. So we've got weather-producing types on the top left, rainfall seasonality on the top right. The regions fall into Western Iberia and the Eastern Mediterranean, which is dominated by winter rainfall. Eastern Iberia and southern France dominated by autumn rainfall, and then southern Italy, Tunisia, and Morocco, which is a combined autumn and winter rainfall regime. What we do...
Clarify, you're not combining Western Iberia and Eastern Mediterranean together?
No, we're not. No. You'll see that it's clearly not, because they're antiphase, as you'll see in a second. What we then do is, using Oxcal, we produce cumulative probability density function plots, and these give you a probability of a radiocarbon date identifying a flood unit during a particular period. What we also then do is identify where the relative probability exceeds the mean relative probability. But also, more importantly, and it's actually not particularly sharp in this slide, which I apologise, what we do in terms of identifying a flood period is it can't be based on one date. There needs to be at least 3 dates within a 200-year period. So in the case of Iberia, which I plotted up here, there are major flood events here and here, but they don't actually qualify within our criteria. So we've actually been conservative in terms of identifying these flood episodes. The detail will emerge in a second. So that's what it looks like. I'll lead you through this in a series of tables and diagrams. These are the probability distributions for the 7 regions. On the right-hand side, you've got various climate and solar irradiance proxies. This is the Olsen paper, I think in 2012, published I think in Nature Geosciences, which has got a centennial and actually better resolution in terms of NAO, and the usual GISP Siberian high record at the bottom. So that is our database, groups in terms of rainfall regime and precipitation regions. What we then do is pick out those periods which lie above the mean in terms of our relative probability distributions. And these are listed here as centennial and multi-centennial episodes of flooding in the Mediterranean based, I say, on both luminescence and radiocarbon. And if you look on the right-hand, whoops a daisy, if you look at the right-hand column here, these are overlapping periods with a number of regions with common periods indicated in brackets. So these are our major flooding episodes, and the numbers in brackets indicates the number of regions listed on the top, where there is evidence in terms of flooding within those centennial and multi-centennial length periods. Okay. What we've also done is actually look at the similarities of these data sets, and what drops out of this is not surprising that there is a significant difference in terms of the Iberian and southern France systems compared to those of the Eastern Mediterranean and North Africa, which you would expect given certainly the winter precipitation NAO relationship we see in terms of a negative NAO, which usually brings extreme events in the Western Mediterranean, and there's either a poor or little relationship between that in the central and eastern parts. So they're antiphase. Okay. Related to this conference, this was the most recent paper that I could find by Kanusi, and identifies this period, the Late Bronze Age, Iron Age environmental crisis between 3,200 and 2,800 BP, with a 300-year drought starting around about, 1200. And this is the proxy records which they have produced with a wet Late Bronze Age and a dry early Iron Age. And those are various proxy records. I'll actually come back to one of them at the bottom in a second, which is the work that we've done recently on the Nile system. When we actually take and look at this period within the fluvial record, so these are multicennial length periods which in terms of the probability distributions indicate there was a greater incidence of large flood events. These are major flood events which are landscape, which are valley transforming. What's interesting is that we actually look at this, shown in red, we have a 200 to 300 year period of major flooding in northeast Morocco, southern Italy, Tunisia, and the eastern Mediterranean, centred around 3,300, 3,200 BP. So the discussions in terms of this wet phase, I'm not saying the extreme average climate doesn't necessarily reflect extreme events, so we've got to be careful here. But nevertheless, on the basis of this evidence, there is certainly a period of major flooding somewhere between centred on 3,300, 3,200. What's interesting, if we actually look at the Iberian Peninsula and southern France, there is no evidence of major flooding in either of those regions in the second millennium BC. More intriguingly for me, if we look at this period between 3,200 and 2,850 BP, there is no evidence of major flooding in the entire Mediterranean in that period. And that obviously coincides, for what it's worth, with the 3.2K event and the 300-year drought. And that's just the way it drops out. If you look at the probability distributions, there is a major gap in the record. And we're dealing with not just a few radiocarbon dates, we're dealing with hundreds. Equally interesting, if we actually look, if we look at the period after this, in the Iberian Peninsula, we have a switch. We've got a 200 to 500 year period of major flooding centred between 2850 and 2750 BP. So, prompted by Neil's recent paper in terms of global planetary change, obviously in terms of the medieval climatic anomaly, the Little Ice Age, there is good evidence in terms of an antiphase relationship between much of the eastern Mediterranean and the western Mediterranean regions itself. But if you actually look at the late Bronze Age, Iron Age crisis, and what I plotted here is just simply the beginning and end of this period, what we see is that in terms of the eastern and the western Mediterranean, they seem to have been significantly out of phase over these periods. So in terms of flooding in southern and the eastern Mediterranean, centred on 3,300, 3,200, basically here, coincides with a multicentennial period of NEO in a positive mode. By converse, in terms of this later period, when we get this very steep transition into a more negative centennial phase relationships of NEO in the Atlantic, that coincides with a major period of flooding in Iberia and southern France. Okay. Building the edifice ever higher, we're doing a parallel meta-analysis in the Nile Basin. And the reason I've stuck this in was that this was done completely independently, and it shows, again, some rather fascinating results. This is mostly based on luminescence dating. These are fluvial units. These are the paleochannels or floodplain deposits. So in case of the Nile Delta, these are fluvial units. They are not coastal lagoon or whatever. There are the major focus of dates either comes from the Dongola reach of the Nile, which myself and Jamie Woodward and Martin Williams have been working for many years, and also a few sites in the White and Blue Nile. This is going to be a special issue that Jamie Woodward is editing of QSI on the Nile, which I think is going to press hopefully sometime next year. So, same exercise. If you look at the bottom graph here, these are probability distributions of dated fluvial units, flood units, either in paleochannel or floodplain systems. You've got various climate proxies from the Kilimanjaro ice core record. There is some debate of whether this is an index of warmth or cold or wet and dry. Actually, the authors themselves can't decide. But anyway, let's leave that. I think there is more consensus that in terms of the Lake Victoria, work by Steger, by Henry Lamb, the Blue Nile, that these are proxies, hydroclimate proxies in terms of the equatorial rainfall from the White Nile and the summer monsoon from Ethiopia. We've then got the Fayoum system in the lower parts of the Nile Valley, and then the more recent stuff that's been done in the Nile Delta. At the bottom, what I've highlighted, and there are at least 5 of these periods, of major channel contraction. The Nile system is an anabranching channel. It's got multiple channel belts. There are major channel contractions that we see around about 6,000, 4,000 BC. But one of the most dramatic, and the reason that I was particularly interested in this, is that we work on the Kingdom of Kush, Kerma in northern Dongola, and basically the Kingdom of Kush was knocked out by the Egyptians, but also coincided with a major channel failure. Basically the Kerma's breadbasket failed as a consequence of a large anabranch which fed floodwater agriculture of about a 500 square area, which failed round about 1250, 1200 BC. What's also interesting as well is in terms we've split floodplain and paleochannel. What you notice in most instances is that in terms of probability peaks, the floodplain almost certainly represents overbank accretion, the building up. Whereas the paleochannels, and actually the preservation of flood-dependent deposits within them, are within contracting, drying out anabranch systems. One of the most dramatic coincides with around about 1000 BC. And what we see, both immediately before 1200, 1300, and then immediately after, and there is very good epigraphic evidence for this, is periods of major flooding within the Nile system, which again mirrors what we see in much of the eastern Mediterranean. Okay, I've got about 3 minutes, I think.
No.
Okay. I'll start this in for Mark. Another PhD student who never wrote up his PhD. I think I've had 41 of them, and most of them have actually delivered. Just a bit of added information. This is the AD 365 uplift event, which affected much of Western Crete. Estimated of 8.5 on the Richter scale. It resulted in the southwest part of Crete with actually 10 metres of uplift. This is the shoreline here with the ferry for scale. For those of you who haven't gone on the ferry on the southern coast of Crete, I suggest you do because it's a fantastic geological playground. What we were doing, there's a very famous American geomorphologist, guy I worked with many years ago, a guy called Stan Shum, had this notion of complex response. And what we were intrigued about was in terms of these river systems in Western Crete, which had been all affected by a stepped uplift, is how they then responded to subsequent and climate and land use change. This is a different paper. I'm not going to go through the details, but the relevance in terms of what Mark was pointing out was this is the AD 365 uplift event. This is, I think, from some of Neil's and Martin Matt-Jones's records. Usual GIST stuff here. This is the Anapodaris system, which actually is located outside of the area of uplift. And these are systems which we've dated primarily by luminescence. And what's intriguing is these are steepening environments. You're dealing with up to 10 metres of uplift in these areas. There seems to have been somewhere between a 200 to 300 year delay in terms of major entrenchment. And we found that rather puzzling. We couldn't explain it until it was suggested or indicated there is this major desiccation event centred on the 5th century AD. And then the major incision, the major entrenchment phases seem to coincide with this wet shift. And then that's we see phases of wetting and drying thereafter. But that's just an additional bit of information. Okay.
You got plenty of time. You're going until 12:15. You got another 15
No,
minutes.
that's okay. I don't like to listen to my voice. Okay. 3 main conclusions. I'll stand here so I can read them. If you actually look at this period, Late Bronze Age, Early Iron Age crisis, 3,200, 3,800 BP, you look at the Mediterranean region, you actually look at the Nile as well. In terms of the Holocene, in terms of the Holocene hydroclimates, it's one of the most major periods of change which we see within the fluvial record. And also, it's marked by significant geographical variability. And I think after I read Eric's book, the question I was left with is, where do these sea folk row from or sail from? And if there is this as there is a geographical variability in terms of wetting and drying across much of the western and eastern Mediterranean, maybe it was dry in the west. And anyway, I won't get into climatic determinants, but I think it's an interesting hypothesis that we may be able to test. In terms of this approach, I say we've now done this in many parts of the world, and using these techniques, we have a centennial, at least centennial-based resolution of major flood events over the last 8,000 years in the Med. And the last point is, I think for so many years in the Mediterranean, we had this polemic: is it land use, is it climate? We go round and round in circles. It's actually both. And actually what land use does, it actually amplifies the climate signal, as we're seeing in many parts of the world today. So hopefully, what did I write here? Hopefully this goes beyond, I was getting a bit, goes beyond the land use control polemic, which I think we need to do. And actually I think there's enormous potential in terms of linking these proxies to some of the societal and the other paleoclimate records. Last but not least, these are the folks in chronological order that have helped me over many years. And obviously, last but not least, and I can see one young lady sitting next to me or standing next to me here, all the archaeologists that have helped me in many parts of the Mediterranean over the last 30 years. Thanks for your attention.